So the question is, with regard to the last presentation, so there are lots of reasons to believe, and there's evidence to support it, and it seems sort of intuitively obvious, that eye movements are driven by sources of information. That is, we tend to look at the things in our environment that are potentially revealing of information about the environment. And so I'm wondering, it seems to me that just looking at the examples of restorative and non-restorative environments, that they have different types of information in them, and perhaps that's the reason why there are differences in the eye movements associated with them. And secondarily to that, does that have anything to do with their restorative power?
Well, we measure this or stimuli with a scale of environmental restoration, and we suppose that our outcomes are related to first that these images are or have different restorative qualities. We are so thank you. We understand that we're working with stimulus that are very complex with built settings and natural settings. They are different qualities, perceptual qualities. But we are thinking more in that these stimulus are restorative or non-restorative, and we are linking these properties with attentional mechanism, like bottom-up or top-down, and this mechanism will be related with the patterns of eye movements.
Yeah, and actually, we have a study ongoing of the restorative effect with fMRI. Oh, sorry, a restorative. He's too close, I'm too far. In which we were actually looking at nature scenes as opposed to positive scenes that did not involve nature as opposed to neutral ones. And we were looking at Brodmann 32 anterior cingulate activation. And it turns out that the urban or the positive but not nature ones actually have this higher level of attentional engagement as measured by the anterior cingulate. So there's almost like a sort of desynchronizing that occurs when you see these natural environments, because you're not directed to anything in particular, but rather the holistic scene, as opposed to these very positive scenes that don't involve nature, in which usually there's some animate object like, a puppy running across the street or something like that sort of business. So there may be evidence of attentional disengagement, which allows cognitive resource to kind of reemerge. And what is that called? Fanciful, the thing Kaplan called it, fanciful redirect or something of attention that's associated with this kind of release that nature scenes have that seems seemingly different than you find in just positive pictures that have either urban or animate objects, but not in a sort of natural landscape environment.
Yeah, I think that was sort of what I was getting at, because if you look at a natural scene, there are not many, under most conditions, they're not sources of information there.
Yes.
Whereas if you look at an urban scene, there are many different things that you may or may not know about, and you're trying to gather information in order to be able to survive in that environment.
Yes, I think that's it's consistent with what we're finding brain-wise, for sure.
On the other hand, you probably did not control for background.
Very difficult.
Did you have farmers and urban people who might find different scenes more familiar or restorative? I mean, I find New York City restorative, And nature scenes just don't do it for me. So, and I mention that because, in fact, all of these experiments are complex experiments, and controlling for the variables and the sample of people that you have is non-trivial, right? The other thing I was going to point out is that we actually have to have a neuroanatomy course before the next meeting for architects. So you know what the cingulate is, or the caudate, or the insula, whatever. Okay, another question.
So that comment was kind of where my question was going, because I was wondering how soon the novelty familiarity factor would negate some of the other, might negate some of the other responses. In other words, if someone spent a bunch of time with those images of angular or rectilinear spaces, would the familiarity of them kind of start to, how soon would that cancel out? Because familiarity is a very strong preference director. And then the other question I had in that same, or the comment that I noticed, is that the futuristic or less familiar environment was quite curvy in the third presentation, and so, or fourth presentation, I guess. So it's kind of interesting that this idea of, you know, people who are from the city get really stressed out when there are no sidewalks, and people who are really familiar with the space and who go to that hospital and know what it's like, whether it's angular or not, they're not going to want to change it to curves. You know, that I think that's really interesting. You could bring familiarity into some of those experiments and see if you lose the effects that you get for preference by bringing the other images into a more familiar, you know, bringing them in ahead of time.
So you're meaning to how to say, to use changing stimuli during the experiment? I mean, also to test the.
You pre-introduce people to images and talk about them.
Okay, no. All the stimuli were totally new.
Right, as opposed to totally new stimuli, okay. Or you're talking to people about, yeah, you could do it by talking about angular spaces and telling a story about them, and then putting them in the space and see if they still have as strong an effect.
In this experiment, we assured that, people saw for the first time during the experiment these stimuli, and to measure the behavioral scores, we used a kind of questionnaire. So we asked if they remembered the design, interior design remembered something to the subject. So the answer they gave is totally subjective.
Yeah,
in fact, this is also a way to work, because it's very difficult to control architecture stimuli, as we were discussing before, because each stimulus could be differently interpreted by different people. Yes. So the first question was about the time. We performed this first analysis in the whole 4 minute perception, but the second analysis will be also focused in the time domain in order to understand, as you pointed out, how much time do I need to elicit that pattern of activation. That's also a point, a good point, of course.
Actually, we did, when we got that reversal, you know, I'm always suspicious when I see something that, you know, looks this way. And so we actually went back and we polled subjects on, look at these images. How familiar are they? How ambiguous are they? How stable are they? How orienting are they with regard to, you know, imagining that these were hospitals? Because we thought, oh, maybe there's something about the instructional thing that we're trying to manipulate here. There was a problem. So what we did is we went back and we asked them to sort of rate them on a scale of how familiar, how ambiguous they were, how orienting they were, and so on and so forth. And it looks like, if I can read these without my glasses, ambiguity, orienting, and transparency of the image were actually related to how likely they were to rate it as a good thing, or I like it as opposed to not. Familiarity didn't contribute to it. Stability didn't contribute to it. Symmetry, surprisingly, did not contribute to it either. So I think you're right. I think the more familiar someone becomes with an environment, but not just familiar, rather, is there ambiguity about it? You know, like that one, well, my first slide didn't show in the presentation, but it's this building, it looks like a beehive, you know. If that's a hospital, I don't even know how to get in to the hospital, much less find my way around in it. So that's an ambiguous kind of representation of the hospital. If you look at the neural pattern that accompanies that one, as opposed to a straightforward Scripps hospital or something like that, well, then you've got a situation in which those factors, I think, are going to come into play. But remember, these are novel, like they were for him, and they're only 150 millisecond presentations. I don't have a lot of time to worry too much about how familiar it is, but I can worry about how ambiguous it looks or disorienting it might be.
Okay, John?
The question I have is related most easily to that photograph right behind you on the screen, in which you see a two-dimensional presentation of an image of walking down this terrific three-dimensional space that is the Salk Institute. I wonder if we aren't making a methodological assumption that when we're showing
Absolutely.
split-second two-dimensional photographs of three-dimensional space, that somehow or other the brain is responding the same way it would if it were in the three-dimensional space.
Absolutely agree. And the way to investigate that would be to literally have a wayfinding video, literally in the scanner with an fMRI safe joystick, and have them moving right around.
Yes.
Oh, so we can't put the cave in the scanner, so it's not.
Yeah. Okay, we have Michael Arbib, and then you over.
I'd like to go back to Marissa because I think there's a lot that wasn't explored in the limited time you had. So the first question is, do you remember the movie Proof?
Yes.
Good. So just for those of you who don't, Proof is an early Australian film by, I think it was one of the Russell Crowe's first appearances, where the hero is blind but doesn't trust what people tell him, so he takes photographs so he can then show them to people later to find out whether their description of the photo accords with what people told him at the time. So just another Australian connection. But the more serious issue is this, that if I understand correctly, the experiment at the moment is going to focus on the congenitally blind and their emotional response. And it seems to me that you touched upon this idea of what you might call sensory substitution, the way in which the acoustic and the somatosensory could play a role. So wouldn't it be more interesting to expand your study from just the congenitally blind to the quotes normal, and also extend it to trying to understand how different sensory activations correlate with the emotional states in the two cases, to see if you could, in the process, understand something of the sensory substitution as it affects the emotional states that are your primary concern.
Yep, you're right. But at this stage, the intention is to actually do a comparative study and look at those outcomes to understand how the vision impaired operate differently. But I just want to just really focus the study to begin with, to get data, because the vision impaired haven't, to my knowledge, haven't been investigated through NIRS. So there's first that information that I want to get clear with. And also I just want those two instances to begin with. So from that study, I intend to do further studies that are comparative.
Now, are there studies already in place on your VIPs in terms of the different distribution and the perceptual systems with respect to similar environments?
There's studies that have been looked at in terms of echolocation and other fMRI studies, but no no nears at this stage.
Yeah. I'm sorry, I'm going to take the prerogative of the chair. I want to follow up a little bit. We just heard about, the other talks are very visual, completely visual oriented. And as we shall discuss in subsequent sessions, there are other senses, right? And I was wondering if you have an equivalent of restorative versus non-restorative environments among the blind.
I don't know, I haven't.
It might be an interesting way to see which of the other channels is actually being substituting for emotion. Okay, we have a question. There.
Yes, I wanted to see if any of you
Could
had
you,
done
could you state your name, maybe?
Helena Van Vliet, I'm an architect.
Thank you.
If any of you had done research on fractal patterns, the self-similar patterns in nature, which have been found to be very distressing, D equals 1.4. Taylor has done a lot of research on that, and they can be replicated in built environments, ordered complexity of nature. De-stressing.
As in reducing.
Sorry, de-stressing, yes.
As opposed to
So
distressing.
these are, for instance, in this image of the Salk Institute, this is an ordered complex image, this, I guess, is an image of the neural cell, is that right? Which resembles a tree ornament, tree shape. So apparently studies have found that fractal, the ordered complexity in nature, which is the self-similar patterns in nature, are very de-stressing to humans. And the range is very specific.
It would be an interesting study to do, because if you think that fractal is the underlying framework of natural environment, keep dividing in half till you get to that last one that, I think I have an old t-shirt that has it on there somewhere, this is the fractal form. Because that may be a fundamental characteristic of what nature is representing in the context of restoration. I've not done the study, but it's an interesting idea.
Well, some studies have been done recently. A gentleman named Taylor has done one. And this is very fascinating to me because apparently the underlying structure resembles that of music, mathematically speaking, which is also a universal language that we respond to on an emotional level.
It might be also related to empathy.
Yes.
Empathy and the form or the shape of the fractal.
Right.
I don't know how universal heavy metal is, for example.
I agree.
Another question? Gentlemen?
So I'm all new to this, so pardon me, but...
He's an architect whose name is Clifford, I think. No?
Not Clifford, no.
No, not Clifford, but an architect, sorry.
On the healthcare project, I'm just curious about the images that you selected, and how do you accommodate for any built-in biases in selecting the images? I mean, how do you deal with that?
Yeah, what we did was a pre-test. We had a whole set of those Miller kind of the archive, and we asked people to sort of rate them on how angular or curved they were and so on and so forth. And I think we just took the sort of a median split, the most extreme angular and the most extreme curvilinear, and we just used those.
Was that separate to the testing program?
Yeah, it was before we set it up. So we asked people, because we didn't want to just have it our own judgment, certainly not mine, right? So we asked, I think, an undergraduate design class to just rate these on the basis of how curvilinear, of various factors. And then we just took the median split, we took the highest ones rated curvilinear, the other ones that were angular, and we just skipped everything in between, except paid attention to these other variables that I mentioned in response to the other question. So it was sort of outside of the scanner before we put them in.
I mean, I was just curious because the extremity of the curvilinear ones was not overly extreme. I mean, it was just curious to me how that.
Yeah, and I wish Patty were here to tell you about that, or maybe she, can you tell us?
So the image selection did take a huge amount of time because we were trying to find real environments. And when we look at architectural environments, you usually land up finding balanced images, not completely curved, not completely rectilinear, certainly not angular. So Hessam, who was the doctorate student who worked on it, collected 200 images. He started with looking at databases from architecture firms like HKS and a couple of others, and then realized that there were no extremes, especially not in healthcare environments, which is where we started. So which is how the priming happened, where you gave them the sound of the healthcare environment, but we were looking for extreme forms, which you find in a Frank Gehry or a Zaha Hadid, but not in everyday architecture. So he got this 200 images sets and then did a series of surveys with undergraduates and graduate students. And then we selected the images. One of the things that he did do was take away the color. So at least the color bias was taken care of. 4 filters were applied. So there were black and white images. There was a sketch rendition from Photoshop where you just looked at the lines and not the entire image. You looked at a graphic filter on it, and then a graphic extraction of the image. So 4 different filters were used as well. And eventually the rating was done in 3 different cycles, right, Mike? Was it 3?
I think so.
Yeah, 3 different cycles because we didn't get enough agreement. So this is just what the real world images are. So I completely agree that if we could do the study again, we would use the Rhino software that Hannah used and maybe take the same set of parameters and change the angularity, change the curvilinearity. We'd have a much more controlled set of stimuli. But we were starting with real environments.
I would love to use that Rift device that we saw on the but make it fMRI compatible. Then we'd have the 3D right in your own individual 3D virtualized world and just monitor brain activity while they're looking through the Rift. We got to make it MRI safe.
Could we move on to another question?
I have a question.
Who has the microphone?
Right here. For Hannah and for Mike. I was just curious, did you control for the order in which people were exposed to different images and see any correlations between the first versus the ones towards the end?
They were random, one sequence, and everybody got the same random sequence. So stimulus 1 was the same for everybody. Stimulus 2 was the same for everybody, but they were randomly intermixed, so it was event-related design.
The reason I ask is because I feel like the way we experience space isn't naturally abruptly followed up by another, image.
Yep.
So do you feel like that played a role in anything in terms of the last ones they were exposed to?
Look, I think there are, and maybe this is an opportunity to introduce this idea that there's nothing magical about these results, and in fact, if anything, they open up a variety of alternative explanations that require experiments of their own to disambiguate and identify the mechanisms that underlie them. And we've kind of stumbled on this one that wayfinding and directionality may be important in utility information environments. But there could be a lot of things that are going on here. Only one of them is the one that we've hypothesized. So rather than answering the question, we've actually opened up a whole number of things like, how 3-dimensional and built is 150 millisecond exposure to something. Your brain amygdala is probably on the alert for these kinds of things because it's part of its role. But you'll notice that the evaluative judgment that followed at 2 seconds suddenly looks like Bar and Netta, like the amygdala business is not really important anymore. I've gone beyond that. It's okay now. I was initially anxious, but I'm not so anymore. So there's a variety of things like we could do would be to look at the activation pattern for trial number 1, for trial number 2, number 3 by category to see if one of these things kind of drops out and gets quicker in terms of it's okay, anxiety removed kind of thing. There are a myriad of things that are going on here. High and low spatial frequency, Bar and Netta did. Visual contours in high versus low spatial frequency inputs. Maybe there's a difference. In fact, there's likely to be a difference. You're going to pick up on it with high spatial frequency more readily than low. Many things to sort of investigate.
Can I just ask, when you start your experiments, do you get a baseline of experience from just being in the MRI? And how that affects?
It's always a relative judgment. So we don't have like, what do you look, You know, what's your brain activation level when you just look at a blank screen? We don't have that. What we do is we contrast across the groups within those options. So there's nothing absolute about these activational levels. They're always relative to each other. And that's just part and parcel to fMRI work. So we don't have an absolute zero of activation. We only have relative activation of one condition to the other. And so we don't have that sort of in the context of it all.
I'm just trying to understand the spatial context of an MRI and the experience of that.
It's what you would see on a computer screen, literally.
It's very...
With a mirror,
yes. Yes, there's a sort of...
computer screen can't be inside you.
I actually experienced it just to test for myself because I was thinking of going down the fMRI way, and it's actually really constrictive. Like if you're
Absolutely.
somebody that's not okay with tight space, and I'm just wondering how much of an impact that has on people's...
Not to mention the
emotional
ambient
responses.
noise level of
That's
this
right,
thing.
yes.
I mean, that's why we don't, you know,
That's
all these
exactly-
experiments are visual. It's because the auditory ones are very hard to do because you get this
Yeah.
going around, you know, as the
Yeah.
magnet twirls around the head. And so you're wearing earplugs, you got headphones on,
Yeah.
you know, it's ambient level.
And you're lying down.
And you're lying down.
Yeah.
I'm sorry, we have a few minutes and there are a lot of...
Oh, sorry.
I'd like to move on. Yeah.
I have the gizmo. First, a comment that I did a study of the San Francisco Public Library. Do you know it, you guys? Any of you panelists? Well, it was done in 1995, and it has a void in the middle. It has some of the audience knows it, right? How many know that space? Okay, and that space, even though it's not a hospital, that round void means that the librarians have to give people directions because they don't know how to get anywhere in the library, and they find it irritating, and the users find it irritating. So I'm sort of adding to your example there, that it's perhaps not just high-stress environments like hospitals, but even just any wayfinding environment.
Utility. Mm-hmm.
And then I have a question for you all, which is, I'm struck by a very ancient feng shui rule about the angular shapes being shar qi and the round curvilinear ones being good qi, good and bad. And I'm wondering, have you all noticed that you kind of have confirmed their ancient observations, and is that of interest to you?
Not until now.
We're going to hear about libraries again from, I think, Michael Arbib, Seattle. A little different. Okay, someone's got the microphone. Do you have it?
I was wondering if any studies, and this would apply across the board, address the different, we're talking about different shapes and so forth, but looking at those same shapes with different colors, because I don't think, correct me if I'm wrong, anything was addressed in color. Now you might say more people like a curvilinear space, but what if that curvilinear space was a dark brown compared to a straight space, and what kind of reaction would people have? It may, in fact, people might not like it. It might be more frightening. So I also was thinking in terms of the word restorative. Did I hear you say that you found New York City restorative? I think the word, and I do too, I think the word might be better to say what's stimulating in a good way. You react in a good way to nature, but there's also, if you look at a burned out forest, which is nature, that's not going to create the same kind of emotion. So I think what stimulates one in a good sense, and that would tie into color. I mean, you show green or you show blue, and that's restorative in certain circumstances.
I think this is a topic of more research about the neural correlates of response to colors. It is important to take into to consider how the influence of different colors can produce different brain response, and maybe it could be a strategy for control in our experiments to take into account the neural response to different colors. It could be a possibility for future studies. This is my opinion.
I have to put one last thing. In terms of colors, I think one has to remember, and how important color is, a lot of people are colorblind. So what might be a stimulating color to one person would be muddy. And then I think when you're dealing with visually impaired people, it's my understanding that they see bright orange and yellows best, and probably can't see other colors. So there's a whole area.
They have,
huh?
Yeah. They have another.
The world's expert on color vision right there.
So I just want to comment about colors and curves, because I think this has it raises an important point, which is that architectural spaces are, in general, the stimulation you get from them is multivariate. And this is a huge problem when trying to understand how a space, there's so many things that are varying in a space like this. Or when you go into Lucan's courtyard up there, the things that are varying are so multidimensional. And it's very difficult as a result of that to sort of tease apart the different things that lead to the experience that you have. And most importantly, there are probably many very complicated, in some cases nonlinear interactions between those different variables that lead to the experiences that you have. It's a really formidable problem that we're facing in trying to understand this.
There's also cultural predispositions as well.
That's right. I mean, yeah. The observer has their own set of conditions under which they perceive things. But I think that the approach which is taken here, and we'll hear more about this in some of the other talks. I know that we're going to hear about this in the session on education on Saturday afternoon. The approach of going in and trying to identify what the key variables are is I think, the only tractable way to approach it at the outset. And then once we get a handle on that, knowing what the key things are, then start to look at the interactions between them.
Okay, I got kind of like a two-part question, I guess. And the first has to do with the difference between a slight curve and a radical curve, and how that affects that concept of wayfinding. Because I would assume that part of it is just when you have a radical curve, you really can't see what's coming, and that poses a threat. But a slight curve gives you kind of the best of both worlds, I guess in theory. And then also, how does the curves play into the difference between a destination type space and a transitional space? So like some sort of curve in, let's say, a patient room or a cafeteria space where it's like somewhere where you're going to, versus the corridors in the hospital and basically areas where you just kind of want to get from A to B.
You looked at degree of curve, didn't you?
Nope.
Oh, I thought you did. I think this is it's a very important one of these interacting variables. I mean, right now, I think I was pleased to see that there was differential brain activation to things that were genuinely considered angular, as opposed to those that were curved. Now that that's established, a parametric way of evaluating degree of curvature and the extent to which it induces meandering versus wayfinding or goal-directed activity is now one of the parametric things that have to happen. Just like introduction of color, high-low spatial frequency, it's a binding issue almost, you know. How much of it is sensory and how much is it is sort of post hoc evaluative, you know, based on what I've sensed. Do I ignore what I sense and just make my own judgment anyways? I mean, it's a very complicated process, as Tom has suggested.
To say nothing of motion and
absolutely.
other things. I think Michael likes to have the last word.
Right. I think this is a comment that may either be flippant or serious, but is certainly timely as the last comment of the evening.
No, I get that.
Oh, okay. The last thoughtful comment of the evening.
Thank you.
Touché, monsieur. We've been talking about restorative environments, and I just want to remind you all, as we approach dinner time, that the word restaurant, it comes from the French word restauration, or restoration. And in a sense, this angles back to our first presentation, where we move beyond vision as the touchstone. And so the classic notion of restoration in terms of food, drink, and then, of course, sleep would be another form of restoration. So I suppose I just leave you as we approach the dinner hour with this thought about to what extent these activities of restoration can resonate with some of these thoughts about, very simplistic, if you'll forgive me, distinctions between curved and angular, as we think about what sort of contexts link into our notion of restoration. Bon appetit.
So let me just say that Michael was trying to simplify things by telling you about dinner, and we'll quit very quickly. But I want you to think about the rest of the next couple of days. There are 5 speakers, as far as I know, will be here. If you have any questions or you want to be enlightened about fMRI or EEG, you can talk to the speakers, because you now know what they know, presumably. Okay, so thank you.
Thank you.